that I'm showing you, just say, hey, can I get another one? Of course, be happy to do that for you. This time is completely for you. So if that's what you want to work on, you can see my screen. We'll just dive right in here. Okay, so this problem right here is about simplifying. You're distributing whatever's on the outside to each of the terms on the inside. There's kind of this intermediate step, which I found is somewhat helpful to show students. You may already know how to do this, but it's where you actually show, the actual multiplication, 7b times b plus 7b times the 8, that multiplication in. Some students can just directly go and say, okay, it's minus 2b squared minus 2b plus 7b squared plus 56b. And just the only maybe thing here is that, b times b, there's both an exponent of 1 there for both of them. It's 1 plus 1 or b squared like that. Is that okay?
Yeah.
All right, so from this step, you're going to combine like terms. All right, so what I mean by that is you're going to look for anything that is the same meaning the same degree exponent, like that b squared and that b squared. The operator goes with it, so it becomes 5b squared. And then we've got minus 2b plus 56b. Color's great. If you don't have colored pencils or way to do that, just you can underline, circle, etc. Some students cross them out as they go, but that is your final answer for that. Any questions on that?
Yeah, that was pretty simple.
Okay, so 3 is the problem that I was expecting you to have. This is something you see on SAT prep. It's the negative between them. So the main thing here is to remember that you do have to distribute this negative to both. A lot of times students don't remember that. It does not affect the first one. So the first one is that 1/2 times v plus 3/2. So that's 1/2 v plus 3/4. And then, like I mentioned, you have to distribute this both. So what sometimes I do here is tell students to change the plus minus. So it's really that minus 1/2 that you're distributing to both. So that becomes minus 3/4v plus 1/2. And then again, you just combine like terms here. So a little more complicated with the fractions. I mean, it's not that bad, but it could, could pose a little bit of issues here. So it's 1/2 v minus 3/4 v. So your common denominator is 4, 2/4 v minus 3/4 v. You can see that becomes minus 1/4 v. And then you do the same thing for the 3/4 and the 1/4 there. 3/4 or plus 1/2. So you make a common denominator of 4. So that becomes 2/4. So your answer is 5/4 when you're all done. All right, so that's that. 5, solve each inequality, graph its solution. Grab this one here. Okay, so the couple of ways to do this problem. I want to ask you what you see when you do this. Do you like to distribute that -6, or do you want to divide it on both sides?
I'd probably distribute.
All right, so by doing that, you get minus 42v minus 18 greater than or equal to 234. From here, you add 18 to both sides. Your goal is to isolate the variable minus 42v greater than or equal to 252. From here, you're going to divide both sides by negative 42. So the thing here that's really important is multiply or divide by a negative, and it has to be the thing you're multiplying or dividing by. That's the only time you flip the inequality. So it does not have anything to do whether 252 is positive or negative. It just has to do with whether you're multiplying or dividing by a negative there. So that's going to flip it less than or equal to. I think this is 6. Are you allowed to use a calculator on this part of the test?
Yeah, it's 6.
Okay. So if we go back to our number line here.
Oh wait, wouldn't it be -6?
Yes. Yes. Okay. So it's a filled in circle. Filled in. And that's because of the less than or equal to or the greater than or equal to that goes with the filled in. If it's the other one, it's the not filled in. And then the direction that the inequality is pointing, if the variable is on the left, is the direction that you shade. So you just have to be careful if you if that isn't clear. The other thing you do here is you could test a point. You could make sure that it actually worked in the original. But that's usually not needed. I mean, you just really need to pay attention to that inequality, whether it flipped or not. Any questions on that?
No, that was also pretty simple.
Yeah. So what I'd like you, I'll just have you jump in here on this problem and do this, but I'd like you to try number 7 here, solving for X. And if you have questions, you can of course ask, but I'd like to see if you comfortable doing something like this on your own.
X would be less than or equal to 5.
Like this, is that what you've got?
Yeah.
Okay, so let me just work this out in case you want to see it later. Distributing that in. So my choice is to add the 2x to both sides, avoiding that dividing by a negative for as long as possible. And then when you add 7, just like you said there, you get x less than or equal to 5. Perfect. So on your number line there, you go to 5, wherever 5 is, filled in bubble and shade to the left. When is your final exam?
It's on Thursday.
Thursday. Great. Are any of your other classes in doubt, or is they all kind of solid for you right now?
They're all pretty solid, except for English, because I have a final in Hamlet.
Ah,
Yeah, so
have
I
you?
have to.
Did you read it?
I did read it, and I understand the gist of the story, except the English they speak is kind of weird.
Very
So
weird.
yeah,
It's tough. But that's I mean, I always struggled with that stuff. But the people that are in that world, they love it. They think it's the greatest literature ever. You can take your, I could live without it, but
yeah. My English teacher definitely thinks it's the greatest.
yes. So you'll get to college and you'll have, every instructor you'll have will think their topics, that, their course is the greatest thing ever. And you just get used to that and go with the
Yeah.
flow. All right. So for number 23, you said we could skip 21. It says to sketch the general shape of each function. I mean, we could just do that and say done, but I think the instructor wants a bit more than that here. I would definitely think that, although I'm not sure. Do you remember how to find the verb? Go ahead.
He has an answer sheet here, and that's pretty much what you do actually.
Okay. All right. Well,
Yeah.
let's go how Matthew figured this out here. So it opens up because a is greater than 1. A is that number in front of x squared. It's U-shaped because it's a quadratic because of that. I mean, that's the only variation on it is if they make the number in front negative, then it opens down. I don't know what 24 is, but it could be. Can you tell me, is 24 a quadratic also, or is it something else?
It's x to the fourth power minus 2x squared plus x.
So there's a couple of ways you could do like 24. You could it does have this shape, but you could also say, well, maybe it's got a couple of more turning points. Did you say positive x to the fourth or negative?
Yeah, it's positive.
Positive. So probably this is what you'll see in the answer key, but they're both reasonably acceptable. Actually a good question to just ask about the shape of things.
Can you go over the rules and like regarded to the shape?
Sure. So for even powers, and these are your x squareds, your x to the fourths, and so on, they always start high and end high, or they start low and end low. So let me get that over here. So they always point in the same direction at the extremes. So like x squared, you can, it's a nice U shape like that. Negative x squared is going down. But the question is, well, what happens in between? So these have what are called n-1 turning points. So if it's x to the fourth, for example, it might have 3 turning points. So a turning point is when it switches direction. See how this switches direction 1, 2, or 3 times?
Yeah.
So if it were x to the sixth, it would switch direction 5 times. It also has to do with the number of crossings, but not completely. I don't think your instructor is asking for a Cartesian graph. They're just asking for like the shape of it, meaning like it starts high and ends high. Now these are for even powers. The odd powers are different. Is this okay? Is this enough
Yeah.
for that? Okay.
Yeah.
Now, if you have a calculator, you can always throw it in the calculator to see what you're talking about. So odd powers are like x cubed, x to the fifth, and so on. So these start low and end high. You can think of y equals x as a straight line. Okay, that starts lower left, ends upper right. Or if they're negative, they start high and end low. And they have the same thing with turning points here. So in the case of like an x cubed, it has 2 turning points. So that could look like turns and then turns again. 1, 2 turning points. If it had like on the right here, let's just say it was x to the fifth, negative x to the fifth, it would have 4 turning points. 1, 2, 3, 4, like that. 1, 2, 3, 4 turning points. These are generalizations. There's a few exceptions, but not at the extreme ends of what it is. The exceptions are like what actually happens in the middle, but your instructor is just looking for the arrows in the right direction.
Yeah, I think about that.
Okay, so let's transition to number 25, if that's okay. What I'm seeing here is you need to know the graphs of parent functions. We kind of looked at a quadratic in the last problem. Here is an absolute value graph. You have to know that. You have to say, oh yeah, that's absolute value. And you need to know that it's V-shaped for sure. Okay. So all the absolute value graphs have the equivalent of a vertex. It's that point where the V comes together right there at the bottom or the top. Can you tell me the vertex just by looking at this?
I forgot where it goes actually.
Okay, so here's the standard form. And so the vertex is h comma k. Does that help, or do you need more explanation?
So the vertex is what's added to x, or added or subtracted to x, and the y-intercept.
It's an ordered pair. Can you tell me the ordered pair from this?
Oh, okay. So it'd be negative. It'd be -4 and then -2.
Okay, so it's actually +4, and this is always kind of unclear. Most students remember it as the opposite. See how h is just the number if it's subtracting. So what most students remember is like if it's subtraction, it's positive. If it's addition, it's negative. That didn't resonate with you, did it?
A little bit.
Okay. Yeah. So the only thing I could do is maybe show you the graphs of a bunch of these to get you to buy into that. It's a rule. It's not really anything. It's not like Hamlet where you're interpreting the language here. It's like, this is what it is. X -4 means 4 right, but the fact that it's subtracting means it's positive. So if it were X +4, the vertex would be at -4. Okay. This is often misunderstood. Yeah. Not sure what to do here. Proceed.
So it's just the opposite of whatever's inside the absolute value.
Yeah, I mean, I don't like teaching it that way, but that's what most students want to hear. The K though is exactly what it is. Like whatever this number is, that is K. So it's a little
It's just a
more.
little weird because absolute value, you're used to absolute value being always positive,
That's true.
but that number can also be negative in this
Yes.
case.
Yes. So the result of the absolute value is always positive, but the thing inside can deviate from that. Like you're thinking of it as the net result of absolute value, but there's actually implied parentheses in here. Like you actually do math operations inside the parentheses before you take the absolute value.
Oh, okay, that makes more sense.
So let me actually give it to you the way that I tell students. H is the number that makes X -4 equal to 0. And it's the number for X, basically. I don't know if that's any better, but you're setting this equal to 0. So you add 4 to both sides and you get X equals 4 for that. Or you visually say, oh, if I put a 4 in for X, 4 minus 4 is 0. That's my H. If you don't like that, go back to what we talked about before. But that's super critical. Super critical that you see that H is 4, not -4, because it makes the graph completely wrong. It's in the wrong place completely. That's why this is so important. Okay. Now the next part is I'm going to show you a little shortcut. Hopefully you like it. So you do graph the vertex for -2. There's your vertex right there. Does the graph of this thing open up, or down? Do you know? It has to do with this 3 right here.
It would go up.
It goes up. Now, what's really interesting is the slope of the V. The slope of the V is actually this, right? The slope is 3 of this line on the right. So going from this starting point, that 3 is the slope of the line. So if you go up 3, 1, 2, 3, and right 1, there's your second point. Up 3, 1, 2, 3, right 1. This has a slope of 3. Have you seen that before?
Yeah.
Okay, good. The other side of the V is a reflection over kind of this text point or this line here, and then you just label the points accordingly. But if you take calculus and they have you graph an absolute value function, this is the shortcut to doing that quickly. You want me to give you another one of these to try?
Yeah,
Okay.
definitely.
Should I make it? Well, tell me what is 26? Is it an absolute value?
26 is it's a different type of problem.
All right, let's try another one of these. All right, could you give me the vertex of this graph?
So it'd be 1 and or x equals 1 and then y equals 4.
So that's
Or
the
1,
classic
4.
mistake. It's -1, 4 is the vertex.
Oh, I said, yeah, I said it equal to, whoops.
Yeah, you gotta. So what you have to do is find something that you feel like, hey, I can do, or it's remembering that it's always the opposite sign. I mean, there's pros and cons of each. I wish I could say, well, this always works, and this is the best way, but it does depends on you, the student. So we put that point there at -1, 4. Does the graph open up or down?
It goes down.
Goes down. So the slope is -2 or -2/1. So that tells you from this vertex point where you're going right, down 2, right 1, down 2, right 1, down 2, right 1. And then you mirror those points across the vertex line, the axis of symmetry there. And that's it. You want to try one more?
Yeah.
Okay. Y equals 1/2 absolute value x plus 3 minus 2. Like the vertex.
So it'd be -3 and -2.
Yes. Sorry, I'm just grabbing some here. -3, -2. Very good. And then what is the slope of the line?
1/2.
1/2. Yeah. Okay. So you go and graph the vertex, -3, -2. And from here, you go up 1, right 2, up 1, right 2. And I mean, you do as many as your instructor wants you to do, something like that. And there you have it. Okay, so I'm ready to move on to 2036. Is that good?
Yeah.
All right. We will definitely have some more time if you want to send over some more problems or have some other questions here for us. Okay, 36. The instructions say to probably simplify, leaving only positive exponents, something like that.
For 36,
Yeah,
simplify your answer should contain only positive exponents.
yeah, they're really sticklers for that. They're not. It's just the way it goes. There's a bunch of rules here to remember. So well, let me ask you, how would you start this problem?
The bottom, so you'd make it 2x to the 8th power.
So that 4 though, see, there's actually a power of 1 above the 2. You actually apply it to both.
No.
So one of the properties is it's like a to the n, b to the n to the power of m. It's a to the n times m, b to the n times m. You've got to apply it to both. So it's 2 to the 4th, x to the 8th times x squared on there. And that's why I asked, because like there's actually many ways you could approach this problem. Just depends on what you like to do. So would you now combine the bottom? Maybe do some dividing. I don't know, where do you see this problem going?
You wouldn't be able to combine the bottom though, right?
So if the bases are the same and you're multiplying, bases are the same, meaning like x times x, you add the exponents. This is one of those rules that you've been studying this kind of latter half of the course. Kind of around logs and exponentials. And So on the bottom, it becomes x to the power of 10. So maybe you thought because of the 2 in front that you couldn't combine them. That's only the
Yeah.
case if you're like adding in here, but because you're multiplying, because they're squeezed together, you can actually have at it and really combine them and manipulate them. All right, do you remember how to combine the x cubed and the x to the 10? It's another rule.
Do subtract?
You do subtract the exponents. So it's x to the n over x to the m becomes x to the n minus m. You subtract. Do you get a note card or anything for this test?
Yeah, I get 1 note card.
All right. You may consider writing some of the things down I've boxed in. Up to you. So when you subtract, though, and I think this is where it's unclear, it's x to the minus 7. It's like, where does it go? It always goes on the top. And then you can decide later on if you need to move it, but it always goes on the top. Now, because it's asking for positive exponents, you will move it to the bottom. And that rule is whatever you have to the negative exponent becomes 1 over that thing to the positive exponent. So that's, another property here. So that means that this x to the minus 7 moves down to the bottom, and it becomes 2 over 2 to the 4th x to the 7 down here. Any questions on that?
So it'd stay 2 to the 4th.
No, you do have to combine these. So you can either say, okay, it's 2 over 16, combine them like that, or you subtract the exponents. You have a choice there. I guess I tend to like, right? I mean, at some point previously, I would have wrote 2 over 16 and wrote that as 1 over 8. This is your final answer, though.
Yeah. All right. I got that all down.
Cool. All right, we got other problems here we can look at. Sorry, let me get back to. Okay, 38. Yeah, I guess we'll just do them in order. 38 has a number of options for how to proceed. You have to decide whether you want to combine the inside part or you want to deal with the exponent on the outside first. Do you have a preference for that?
Usually I deal with the exponent outside first.
Okay. So I take that to mean that you want to multiply every exponent by 4. That's where you got to make sure, okay, you actually get all of them. Okay, so that is x to the 12th, y to the minus 12 over x to the 8th, y to the minus 16, x to the minus 8, y to the 12. Now, what do you see from here? Do you want to combine the stuff on the bottom, top and the bottom? What kind of do you see?
Probably combine the denominator first.
Okay, so like x to the 8th, x to the minus 8. What does that become?
Yeah.
So you add the exponents, right?
Yeah.
That becomes x to the power of 0. And x to the 0 equals 1. So that's another thing maybe to write down. All right. How about the y to the minus 16, y to the minus y to the 12?
That would become, oh wait, they both add, so it'd become y to the negative 28.
They're one's positive, one's negative though.
Oh, whoops, I was looking at the wrong thing. So it'd be y to the negative 4.
Yeah. Now, what I said before in the previous problem that you write it on the top, that only applies when you're dividing. When you're multiplying, you keep it on the bottom. Is that okay, or is that need some
Yeah.
more discussion? All right. So now, I mean, there is a 1. We don't need to write it. We can if we want. So now you've got to combine the y to the minus 12th over y to the minus 4th. So you're gonna subtract those exponents. You're gonna subtract -4. So minus 12 minus a minus 4 is y to the minus 8. That's when it goes in the numerator when you're dividing. You just, whatever it is when you're dividing, you go back and put it in the numerator and then deal with it later. Last step here, if you have a number to a negative exponent, it becomes 1 over that exponent to the positive power. So this becomes x to the 12th over y to the 8th. That's a really solid question. It's a really tough one for most students to be able to work through all of that and not end up with like a y in the wrong place. Can definitely make one up like that if needed. 40 is a little bit more like 38. But we'll move to that one if you're ready for that.
Yeah.
Okay. Do you have any graphing rational functions on this review?
Let me check. What is a rational function again?
So that was the stuff we spent a couple lessons on. Your graphing, this and this and maybe some.
Oh yeah, I have that.
Okay. All right. Well, let's finish up this problem here. I made that way too big. When you look at a problem like this, are you drawn to the exponent? Because that's what you told me in 38.
Yeah.
Okay, so that's important to deal with first. While you don't have to, it is the best thing to do. So you multiply the exponents n to the 6th times mn to the minus 4th over 2m squared, like that. And you have to decide what you're going to do next. I think you've been working on like the numerator, the denominator first. I would recommend that here. So what I mean by that is n to the 6th times n to the minus 4th. You're gonna add those exponents. So the add just means add whatever they are. Like one's positive, one's negative, you're still adding. They're both negative, you're still adding. Yeah, that's the extra operator you're adding. And so it's n to the power of 2. So it's n to the power of 2 over 2m squared. What do you see now from here?
Can you simplify it further?
Yes. So it's m to the power of 1.
Yeah.
Maybe that helps.
Yeah, I see it now. Would you subtract the m squared minus the m1?
So it's m1 divided by m squared. That becomes m to the 1 minus 2. You always
Oh,
subtract. You always subtract, like if it's positive, but you put that subtract between them. So it becomes m to the minus 1. That always goes in the numerator.
so would it be m to the minus 1 and then m squared divided by 2?
Yeah, so it's m to the minus 1 n squared over 2, but you can't leave it with the negative exponent.
So it'd be n squared over 2m, 2m to the first power.
Yes, n squared over 2 m to the power of 1 or 2m, like that.
Okay, got it.
There's a lot in each of these ones. Do you know if your exam is multiple choice or free response?
It's multiple choice.
Multiple choice? Okay. Yeah, you gotta be really careful because you really want to work through the problems and match them up. Rather than try to like just use the answers, but it's easy to just make a little mistake here and there.
Yeah.
Okay, that covers everything you sent over. I always have some time left, so if you want to send over some more problems, or if you want to have me make some up like the ones that we've looked at, totally up to you. Just let me know what you'd like to do next.
Can we do more like these actually?
Sure. Do you have a couple more there, or do you want me to just make some up?
I actually have 4. Hang on.
Okay.
We'd probably only have time for one of them, but I think it'd be helpful to me because these ones are kind of long.
Okay. Yeah. I mean, just send over whatever you want us to do. You're kind of a perfect case study for what I tell new customers. It's like, hey, get some lessons, and you'll see some improvement. And like you said, things have been turned around. Maybe you could have done it without me, but you now have a resource if you're ever stuck again. And that's the
Yeah.
idea. So yeah, I agree. This one's kind of awful. So the thing here is, like, I know in the previous round, we're like, hey, let's put that 2 to everything. You can absolutely do that, but you really need to remember that there's a 1 and a 1 and a 1 above each of those 2's. So if you want to do it that way, which is totally fine, I don't have a problem with it. Just be sure that you remember that. I personally, and this is just a preference, I would probably clean up the inside first, but both ways work. They're not wrong. So 2 squared, p to the minus 6, q to the power of 6, r to the minus 2 times 2 squared, q to the minus 2, r to the minus 8, all over 2 squared, p to the minus 8, q to the 4th, r to the 6th.
Got it.
So now, lots of options here. I guess I'd probably handle the numbers first. So I'd maybe say, okay, that's 4 times 4 up top over a 4 on the bottom. And notice I'm dealing with let me cross those out here maybe. So the result is that that becomes 4. So that means in my numerator, there's a 4. And I might, just for clarity, I might rewrite stuff so that it's next to each other, like q to the 6th, q to the -2, r to the -2, r to the -8. Something like that. So then what this does is it allows you to combine the exponents here for q and then for r. So when the bases are the same, you add the exponents. So you're gonna have on the top 4p to the -6, q to the 4, 6 plus -2 is 4. And then for the r's, it's -2 plus -8, which is -10. Again, when you're multiplying, you just keep them in the same position. It's when you're dividing that you always move it to the top. On the bottom, it's p to the -8, q to the 4, r to the 6. And now it's really 3 separate problems. It's really, if you can visualize, it's kind of like there's these things, the p, and there's the q's, and then there's the r's. So for the p's, it's -6 minus a -8. I don't recommend you try to do it on the fly. Just write it out. Easy to make errors there. For the q's, it's 4 minus 4. And for the r's, it's -10 minus 6, which is -16.
Now would those all go on the top?
Yes. So it's 4p squared, q to the 0, r to the -16. So the whole top thing only applies when you're dividing. And then you're supposed to remember, oh yeah, if anything is to the 0 power, that's 1. So that's 4p squared, r to the -16. And then you move the r to the -16 to the bottom. So it becomes 4p squared over r to the 16.
Okay.
All right, so I think we can do 43. Or do you want us to do something else?
Yeah, we can do 43.
Okay. And there's no value to this. I mean, other than doing it for this class, there's actually no real application of this. It's a great kind of a college math placement test question, but it's not really useful for anything like engineering or science. But nevertheless, you got to do it. To write the exponents, even for the variables. That way you don't miss that. And just like before here, you're going to multiply that -3 to everything. So 2 to the -3, q to the -3, p to the 9, r to the 9 over 2 to the -3, p to the 6, q to the 12th, r to the 3rd times 2 to the -3, q to the -3, r to the -9. So it's kind of a flip of the last problem. Like now you need to work on the bottom first. We could work on the numbers. We probably should. So this is always kind of awful, but it's the top is 2 to the minus 3, the bottom is 2 to the minus 3, 2 to the minus 3. I would focus on what cancels. So the one of them cancels top and bottom, leaving a 1 up top. So this 1 over 2 to the minus 3. This is the other property. If you have 1 over x to the minus n, it becomes x to the n. So it's just the one that goes the other direction. So negative exponent on the bottom comes up top. So we're kind of dealing with the numbers differently than with the variables to the exponents, but they're numbers, so that's okay. Point is all of that results in an 8 on the top. Q to the minus 3, P to the 9, R to the 9, and then we'll just order these on the bottom here. Let's go Q to the minus 3. So I'm getting rid of that one. P to the 6th. Sorry, I misordered these. There is a Q to the 12th there. P to the 6th. And then R to the 3, R to the minus 9. Just kind of reordering them to make them a little easier to work with. A lot of rewriting here. I mean, you could try to manipulate them as you go. That's Q to the 9th, P to the 6th, R to the minus 6. That's minus 3 plus 12. And then 3 plus minus 9. So now you've got 3 separate problems here. Minus 3, minus 9 for the Q, that's minus 12. Because you're dividing goes up top. 9 minus 6 is 3 for the P. Last one is 9 minus a minus 6, which is 15. R to the 15. And then the final step here, you move that one with the negative exponent down to the bottom. 8p cubed R to the 15th over Q to the 12th. Kind of perfect timing here. Pretty much got out of time. Hopefully you got all that down. We'll send you the notes here shortly. I do have some time tomorrow if you need another lesson, but maybe you've got everything down you need. You said your finals on Thursday.
Yeah.
So you've got a little time here to review, but if you understood this, you're probably in great shape. So if I don't hear from you, I hope you have a great, holiday and New Year and all that, and I'll be available next year if you need my help.
Yeah, you too.
Okay, thanks. See you later. Bye.
See ya.